Okay, so 4 is called graphing sine and cosine. Okay, so you're just going to basically take those two functions and we're going to do the same translations that we've done with everything. So we're going to move them up, we're going to move them down, left, right, and we're going to squeeze them and we're going to stretch them. Okay, so the first thing that we need to know is what the parent function looks like. Okay, does anybody know what the sine of x looks like? It is a squiggly line. Okay, so it is actually a wave, okay, which is, anybody in music or fond of music? Okay, so you've heard of sound waves, right? Okay, this is the function that they use to represent sound waves. Okay, so you've seen like the amplitude and the amplifier things. Okay, so we need to make sure that we're very exact when we draw these functions. So I have this little table here. You guys have your unit circle because mine doesn't look very good up there. The first thing I'm going to do is I'm just going to come up with some ordered pairs, and then I'm going to plot them on the graph. Okay, so it's been a long time since we've done something like this. Very, very basic. Okay, so everybody looking at the unit circle, I'm going to start with looking at the radians. Okay, so at 0 radians, we're going to find the sine. So what are we looking at for the ordered pair if we're looking at the sine? Are we looking at the x or the y? The y. Remember, sine is equal to the y over the r. But since we're using a unit circle, we're just going to say the r is 1. So we're just looking at the y. Okay, so what is the y value at 0 degrees? Or 0 radians, same place. 0, right? Okay, if you go up a little bit higher and look at the pi over 6, what is the y value at pi over 6? 1/2. So it goes up a little bit. Okay, and then you go just a little bit more. Pi over 4, square root of 2 over 2. Now, for this one instance, the square root of 2 over 2 is not very easy to graph. So let's convert that into a decimal real quick. Can somebody type in the square root of 2 over 2 into the calculator and tell me what that is as a decimal? 0.71. 0.71, perfect. Oh, that looks bad. 0.71, that's what that says. Okay, so moving up, what is pi over 3? The square root of 3 over 2, good. Can we get a decimal for that? Anybody know what the square root of 3 over 2 is equivalent to? 0.87, okay, that'll be easier to use. Okay, what about at pi over 2? 1, exactly 1, good. Okay, so now we're moving into second quadrant. What's 3 pi over 4? Good, so square root of 2 over 2, which we just said was equivalent to 0.71. Okay, then it gives us pi, so it's pi, so we're moving a little bit quicker through the unit circle. 0, back to 0. And then what about at 5 pi over 4? Good, negative square root of 2 over 2, which is the same as negative 0.71. Okay, what about 3 pi over 2? Negative 1. And then we go back to 0, or 2 pi, and we're back at what value? 0. Okay, so now what I'm going to do is use my little fancy grid that's already cut into nice little increments, okay, and plot all these points. Okay, the one thing that I want you guys to realize is, what is my x-axis representing? Okay, what specifically though? It's kind of hard to see. This says 0, this is pi over 2, pi, 3 pi over 2, and 2 pi. They're radians. Okay, so it's putting the x-axis into increments of radians. Okay, all right, so at 0, we're going to plot the point 0, 0. So that would be directly at the origin. Okay, pi over 6, okay, which is actually this very first increment. Pi over 6 is right here. Okay, pi over 6, I'm going to go up 1/2. So what I'm going to do on my y scale, let's go up, let's say this is 1/2 and this is 1. Okay, so I just label my y scale. Okay, so I'm going to go to 1/2. Right there. Okay, and then pi over 4, I need to go to 0.71. So pi over 4 would be like halfway in between pi over 6 and pi over 3. So this is pi over 4 right here. Okay, so I'm going to go up to 0.71. So let's see if this is, here, let me put this in terms of decimals instead of 1/2. This is 0.5. So this would be like 0.75. So we're like right there-ish. Oops. Okay. Then I'm going to pi over 3. So at pi over 3, so this first or second increment is exactly pi over 3. I'm going to go up to 0.87. So that's like right about there-ish. Okay. And then a pi over 2, I'm going to go up to 1. Okay. And then my next one is 3 pi over 4. So 3 pi over 4 is like right in between pi over 2 and pi. So 3 pi over 4 is right here. And I need to go to 0.71. So right about there. Okay. And then it goes to pi. And pi, my y value is 0. So it goes down, crosses the x-axis right at pi. Okay. 5 pi over 4, so that's going to be directly right between pi and 3 pi over 2. I would go to negative. Let's see, we want this to be 0.5, negative 1. So like right there. Oops, that's not right. There we go. Right there. Okay, so then at 3 pi over 2, that's at negative 1. And then 2 pi goes back to 0. Okay, so we kind of already discussed what this should look like, right? You can see this wave starting to emerge. Okay, so to the best of my ability, I'm going to connect these dots. Oh, that's pretty good. Not bad. Okay, so what I just drew is one revolution of the sine function. Okay, so this is the sine of x. Okay. Now if I take my calculator, okay, and I want you guys to be able to draw these in your calculator too, just to kind of verify what things look like, but you have to know how to do it correctly. Okay, so if you want to do this in your calculator, okay, we want to type in the sine of x. Okay, what mode do I want my calculator to be in? Radians. Okay, so I need to hit mode and make sure my mode is in radians now since I'm graphing. And then the next thing that I want to happen is I want my axes to be in terms of pi's. Okay, so the calculator has a quick fix for that instead of going into the window and making it what we see. If you hit zoom, you can see that 7th option. Everybody see it? So hit zoom 7 and it will take you into a trig mode. Okay, so what is happening here is you can kind of see the increments that I drew on my paper. Okay, this first increment here is pi over 2, and then this one is pi, and 3 pi over 2, and then 2 pi. So it goes from negative 2 pi to positive 2 pi, and then on the y scale it just goes from negative 4 to positive 4. Okay, so it's kind of similar to doing like we usually hit zoom 6 for a standard 10 by 10. When we're doing trig, we want to use the trig one. Okay, and sometimes it will be different depending on what we're drawing, but that's the best way to kind of see it. Okay, if I zoomed out a little bit, just so you can see that this function keeps going, you can see that this wave continues infinitely. So it goes up and down forever. Okay, so when we are drawing sine functions, I want you to be able to draw one full revolution perfectly. Okay, I should be able to see exactly how high this is going, how low it's going, and where it crosses the x-axis, or maybe the whole function moves down. Okay, so I'll kind of talk about that as we do more examples. Good there? Bless you. Okay, let's do cosine. I'm going to do this a little bit faster if that's okay with you guys, just to not bore you. Okay, so cosine, same thing, we got the unit circle, go to 0. Now we're looking at x because we're doing cosine. What is the x value at 0? 1. Okay, I'm just going to use pi over 4 increments, so I'm going to skip pi over 6. What's pi over 4? What's the x value at pi over 4 on your unit circle? Square root of 2 over 2, so that's about 0.71. Okay, and then I'm going to go to pi over 2. Okay, so pi over 2, what's the x value at pi over 2? 0. Okay, and then at 3 pi over 4, what's the x value? Good. So about negative 0.71. Okay, and what about at pi? Okay, and then what about at 5 pi over 4? Good. And then what about at 3 pi over 2? Back to 0, and then when we go back to 2 pi, which is the same as 0, we get back to 1. Okay, so before I start drawing this, does anybody know what the sine or the cosine function looks like? Okay, it is also a wave. Yeah, it looks very, 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 very similar to the sine function. Okay, so let's do the same increments. We got 0.5, let's go to 1, negative 0.5, negative 1. Okay, so at 0, we have a y value of 1. Okay, so at pi over 4, we have 0.7, so that's about right there. Okay, at pi over 2, we go down to 0. Okay, here's 3 pi over 4, that's halfway. We're at negative 0.71. Okay, then at pi, we're at negative 1. 5 pi over 4 is negative 0.71. And then 3 pi over 2, we go back to 0. And back to 2 pi, we're back at 1. Okay, so connect the dots. Okay, so here is a cosine wave. Okay, so if we zoom out super far, if I go back to my calculator, and I'm going to type in just the cosine of x, just so you can see this. From way back where you're sitting, do they look exactly the same? Can you tell the difference between a sine and a cosine function from where you're sitting? Not really, right? Okay, so what we can say is there is a difference, and I'm going to type in both in and go back to my my zoom trig so you can see exactly what I'm looking at. Okay, so the first one is the cosine function. And the second one will be the sine function. Okay, how would you describe these two? Okay, so say that one more time. Sine crosses through 0. Very good observation. Sine crosses through the origin. So where does the cosine one start? 1. Okay, cosine starts up top at 1. Okay, that's really important information when we start graphing these on our own without the calculator. Okay, but other than that, if I just took a sine function and shifted it to the right or to the left, pi over 2 units, they would overlap, right? They would be the exact same function. Okay, so tangent is completely different, and we'll do that one next. It's totally different because you do y over x, so you get something very different. It actually looks really cool, but we'll save that for later. Okay, so what I want you guys to specifically notice. Okay, so this one right here is my cosine of x. Okay, so I asked for you, or I'm going to ask of you, to be drawing one full revolution of each of these. Okay, I don't want you to just draw one wave forever. That would be ridiculous, okay, and not very useful. Okay, so what I want you to draw is a sine wave is one revolution. So what would you kind of describe if we just pretended that this was the start and this was the finish for this function? What would you say that looks like to you? What? A hill? It does look like a hill. A John Travolta? Oh, it does look like a John Travolta, like zoomed into the wiggle part. I see what you're saying, yeah. I kind of see like a Z, an S. Kind of see that? Okay. So whatever it takes for you to remember, that's what you should be drawing anytime you see a sine or drawing a sine function. What would you say the cosine looks like? It's kind of like a U, right? So that's kind of like a valley-ish more, because U, we say U for parabolas, but the parabolas like go up to infinity. These max out at 1. Okay? Okay, so here's important information you need to write down. Okay, I'm going to start by giving you the parent function of a sine and a cosine. So notice that I wrote sine. This is in terms of sine on this particular one. It can be in terms of sine or cosine or tangent or cotangent, whatever your trig function happens to be. That's going to be the same. Okay, so that should look really super similar to any other function we've ever graphed before. Right? It is not incredibly different. Okay, so the pieces of a sine and a cosine function or a trig function are a little bit more informative. Okay, the first thing they say is the A is the amplitude. Okay, so the amplitude is like how high and how low the function goes. Okay, they say that by the half distance between the max and the min. Okay, so if I was going back to my sine and cosine functions, what was my amplitude? Okay, how high and how low did they both go? They both had an amplitude of 1, so I'll always use positive values for amplitude. How high and how low. Okay. Period. Just so you know what a period is, this is actually very important, is the distance between any two sets of repeating points. Okay, which is one full revolution. Okay, so the idea of our little sine wave, I only drew kind of the S piece of it. We're just going to draw one period instead of drawing a giant sine wave. Okay, so it's possible to take that sine and squeeze it in like, or spread it out fat. Okay, so the definition of the period is 2 pi over b, one full revolution. Okay, they will ask you a question about the frequency, which by definition is b over 2 pi. You do not use frequency for graphing. That'll just be like a separate scenario where they'll say, oh, what's the frequency of this graph? Oh, sure. Okay, am I good to scroll down a little? Okay, and then the phase shift and vertical shift, this is not brand new at all. This is exactly the same as any function we've ever done before. Okay, if something is inside the parentheses, it's a left or right shift. If something is on the outside, it's up or down. I don't know why that D is floating out there. Oh, that was the D, that's why. I get why. All right, ready? So I'm going to show you how to draw these, given the information. All right, so first example. Did I go too fast? Is everybody with me? Let me know if I need to go back. All right, so here's my first example. We're going to do a sine of x over 2. Okay, so basically what we're going to do is we're going to go through and identify all of those important parts. Okay, so first of all, what is my amplitude? What is the value that's in front of the sine? 1. Okay, so that means my wave goes up 1 unit and down 1 unit from my midline. Okay, the next thing I want to find is my period. Okay, by definition, that is 2 pi divided by the b. Be very careful in this case. What is my b value? Very good. Everybody see how it's 1/2? Because if you divide by 2, that is the same as multiplying by 1/2. Okay, so if I have 2 pi divided by 1/2, divided by 1/2, what's that the same as? Multiplying by 2. So what's 2 pi times 2? 4 pi. Okay, so that means we're going to stretch this out. It's going to pull out. Okay, the next thing I want to list is any phase shift or vertical shifts. So do I have any left or right movements? No. Okay, so there's no phase shift. No phase shift. Is there a vertical shift? Is there any adding or subtracting on the outside of parentheses? No. Slash vertical shift. Okay, so this is a pretty straightforward function. Not too exciting. So this is how I would like for you to always draw all functions. Okay, so you're going to draw your axes, and you're going to label them, okay? If you do not label them, it'll be wrong. Okay, so you're going to make 4 little tick marks on the x-axis to the right. So 1, 2, 3, 4. Okay, and that's going to make sure that you're drawing 1 revolution of our sine curve. The 4th increment will always be whatever your period is. Okay, so what is my period? 4 pi. So this 4th increment is 4 pi. Okay, now I'm just going to quickly label all the way till my first one. So I'm just going to go half and then half of that. Okay, so what's half of 4 pi? 2 pi. So this right here is 2 pi. And what's half of 2 pi? Pi. Okay, so this one is just going in pi's instead of pi's over 2 like our last one. I'm going to do 1 in the negative direction just because it makes me feel better, like it feels like a continuous thing. Okay, the next thing I'm going to do is label my y-axis. How high and how low do I need to go in order to draw this? To 1 to negative 1. Good. 1 to negative 1. Okay, so now I'm going to start drawing. Okay, I'm drawing which function? The sine. Okay, so where does the sine start? 0, 0. Okay, so I'm going to draw it. So watch how this goes. This is kind of cool. So the first increment, it's going up, right? Okay, so it's going to go up to its max. So on the first increment, it's going to hit the max. Boom. Okay, on the next increment, it's going to cross the x-axis. On the third one, it's going to hit the minimum. And on the fourth one, we're going back to the x-axis. Okay, so now I'm just going to connect those 4 dots. Well, I lost my dot. There we go. Okay, so remember you're drawing a wave that goes up and down, but all I want to see is just the one little S because we're doing a sine. That's it. Not bad? Not too bad? Okay, let's do another one. Let's do this one. All right, are we ready for this one? Okay, so we got a little bit more happening on this one. All right, first of all, what's my amplitude? 3, good. So 3, the number in front. Okay, then I'm going to find the period. So that's 2 pi over my b value. Which one is my b value in this case? 2, the value that's right in front of the x. So 2. So we'll simplify that real quick. The 2's cancel, so what is my period? Pi, good. Okay, do I have a phase shift? Is there adding or subtracting inside the parentheses? Yes, so I have a phase shift. So I have a phase shift, I'm going to say PS for phase shift. First of all, what direction is my phase shift in? Ooh, which one? I heard both answers. Which one? To the right. Right. Okay, so phase shift is C over B, by the way, in case you didn't remember that. So we're ignoring negatives because we're taking care of the negative with which direction we're moving. So how far to the right is this moving? Pi over 2. Very good. So I'm going to say pi over 2. So pi over 2 units to the right. Okay, last part, do I have a vertical shift? Is there adding or subtracting on the outside of the parentheses? No, so no vertical shifts. No vertical shifts. Okay. So I draw my little grid. It's going to look the same every time. I'm going to draw 4 increments. 1, 2, 3, 4. Okay, and what is my 4th increment going to be? Not my phase shift, my other one. My period, which was pi. There you go, pi. So 4th increment is pi this time. Okay, so now I want to go half of pi. What's half of pi? Pi over 2. And what's half of pi over 2? Pi over 4. So a little quick tip with dividing by 2, or you just multiply the denominator by 2, right? What's that? I'm distracted by sounds. Okay. Okay, so now we can, we got to label our y-axis. How high and how low do we go? 3. So up 3, down 3. And you could draw just one tick mark and just label it 3. That would be fine. Whatever you want to do, as long as you label it. Okay, so we're going to draw a cosine function. Okay, so the cosine starts at the amplitude and goes down and back up to the amplitude, but we have a phase shift. Okay, so my phase shift is going to be moved to the right pi over 2 units. Do you see where I'm going with this? Okay, so if I'm taking a cosine function that usually starts right here and shifting it to the right pi over 2 units, where is it going to start? Right here, right? Is that where you all pointed? Good. So hopefully at this point you realize that if I'm going to keep going and drawing this, I need my little x-axis to extend out because I need 2 more increments to finish it, right? So I'm just going to kind of extend this, draw 2 more increments. I could label them. I don't think it's imperative that you do.
Just start at -3.
Yes. You could. If you're continuing on. Yes. Yeah, you're right. Which is fine. I'm not going to teach it that way though, because I want it just to be dry and click. Okay, so from my amplitude, I'm going to go to the right and I'm going to cross. So on a cosine, you cross first. Okay, on the second increment, I'm going to go to a minimum. Third increment, I'm crossing. In fourth increment, I should be back where I started. So if I started at a max, I should finish at a max. Okay, so if you connect those dots, draw a perfect little, it's kind of almost like a V that has like edges out. I don't know. So make sure that you're not drawing this. Did you just draw this? That is not a wave. That's like a, I don't know, something else. Well, it looks like a V, yeah. So make sure it's wavy and like curved, it's not straight. Okay, so are we good with that? So maybe you guys extended this. I don't know how many people did. I know Angela started thinking this way. So he continued on and started it there. Okay, if you're drawing it that way, that's totally fine. I'm not going to teach it that way though. I'm going to kind of be very consistent in the way I teach it because we're going to end up doing tangent, cotangent, secant, and cosecant. And if you just kind of do everything for all of them, it just keeps it very simple. Okay? All right, let's do one more that has a vertical shift. This one is about as complicated as they might give you. Well, maybe they would give you one that had a phase shift too. Not too bad though. Okay, so first of all, what is my amplitude? 2, very good. Everybody say positive 2. Okay, so amplitude is always a positive distance. Okay, my period, 2 pi divided by the b. What's my b in this case? 1, good. So 2 pi. Do I have a phase shift? Yes. So I do have a phase shift. Which direction is my phase shift? To the left pi, very good, nice. Left pi. Ooh. Okay, and then I also have a vertical shift. What direction? Up 1, very good. Okay, so do make sure on your shifts that you are saying specifically what direction. Yes?
Phase shift, that what direction?
Same as any function. If it's a plus on the inside, if you subtract, it's to the right. And if it's a minus, you go to the left. No, I said that wrong. Sorry, my bad. Listen carefully. Let's try that again. If it's a plus, you go to the left. Minus, you go to the right. Does that make sense, or did I just confuse you more? Good. Okay. All right, so here we go. Here's my axes. So I'm going to pull out and to the right. I'm going to draw 4 little increments. 1, 2, 3, 4. Okay, and what's my 4th increment going to be? What? 2 pi, 2 pi. Okay, and then what's half of 2 pi? Pi, and what's half of pi? 5/2. I'll just go 1 in the negative direction, just makes me feel better, I don't know why. Okay, and then for my amplitude, how high do I need to go? Ooh, okay, so I have some people who are thinking about my vertical shift too. Okay, so do you see that I do have an amplitude of 2? But if I have a vertical shift of up 1, see how I'm going to actually go up to 3? So I'm going to go to 3, so I'll draw 3. What I'm going to do, though, is I'm going to put... Actually, that's good. Okay. I want to draw, in this case, a midline. Okay? I didn't draw a midline before because my x-axis kind of served as my midline. Do you guys know what I'm saying by the midline? That's not like an actual term. It's like a nullity term. Okay? So I'm just going to say there's like this middle of the line where it comes back and crosses every time. So I'm just going to draw the midline. And the midline will always be whatever your vertical shift is. Okay? So where's my midline? At 1, right? So that will just kind of help. I'm going to draw it like a dotted line, kind of like how I draw asymptotes, just to help me draw it. Okay. All right. So this one is a little trickier. You ready? I'm gonna draw in green. Okay. So first of all, we got a sine function. Where's the sine function? Usually start at 0. Okay, but we have two shifts, right? Okay, we've got an up one, which takes us to the midline, and then we also have a left pi. So where is my starting spot going to be? 2 increments, right, to the left. So you see how I'm 2 because pi is 2 to the right. So if I'm going left, I need to go 2 increments to the left. Okay, so I need to kind of extend on my x-axis, give myself another increment. I'm going to even label it because it's an easy one to label. Okay, so there's going to be my start. Okay, now the next thing I want to think about is, did anybody else notice that there was a negative in front? Okay, so a negative flips every function upside down. Okay, so if normally we had a function that went up and then down, if we flip it upside down, what's it going to do first? It's going to go down first. Okay, so that means I need to go down to my minimum. Okay, so remember that my amplitude is 2. How low am I going to go? To -1. Very good. Does that make sense to everybody? Okay, so that first increment to the right is going to be a -1. Ooh, I should label my increments. 1, 2, 3. That was bad of me. Okay, so then where am I going to go from here? Back to my midline, right? 0, 1. Okay, then where from here? To 3, good, to a max. Okay, and then from here, back to the midline. See how helpful that midline is? Kind of surprised that I haven't taught it before. Okay, so I should have that S shape for my sines. Okay. What do you think? Not bad? It's a little more exciting than usual. Okay. All right, so here is your assignment. 2 through 38 evens. But do skip number 30.